Welcome everyone to a video where we attempt to build a 2D game from start to finish in one video. Now before we start to actually code our game, we need some sort of a blueprint. The style of the game that I'm trying to build is based on the Ketchapp style of games. I think it's really cool what they do with their games. It's very simple, it's very unique, and it's very attractive to play. So we're gonna do some sort of a game that looks something like a Ketchapp style of game. Now before we actually start coding and putting objects into our game, we need some sort of a blueprint. The best way that I've found to make some sort of a blueprint is by using Photoshop. Now we have a resolution of 9 by 16, which is the resolution of any mobile device, basically close to it. And now in here we're gonna create some sort of a blueprint. Now my idea for the game is that we have some sort of a drop that spawns somewhere up here, and then it slowly drops down into our screen, and then down here we have some sort of a bucket, something that looks like this, maybe a little smaller, and then using our finger or our mouse, since we're still designing it into Unity, we can move this bucket around to catch all of these points. Now these can be any mesh you want or any texture you want, and that's basically the idea of the game. Okay, here is our interface inside of Unity. I've named my project Orbit. You can name it whatever you want. And now let's populate this scene. For this project, I am going to use this simple icon pastel tone. You can obviously use a different one, or you cannot use it at all. I just like it because it's very simplistic and it's very nice to look at. Okay, now let's start actually building the game. We're gonna switch the scene view to 2D. Now we have a 2D view of our game. Now since we're building a 2D game, we don't need a directional light and we don't need a background sky. So we're gonna go to Window, Rendering, Lightning, and inside the environment we're going to change the skybox material to a material that we want. For now we're gonna do none. And since we don't have a background material, we can change our background color to any color we want. And later on in our game, we're going to do a function that loops through colors like this. Okay, now let's make a basic function to spawn our game objects. So first of all, we're going to create an empty game object and we're going to call it Game Manager. And then after we create a game manager, I'm going to create a new folder and I'm going to call it scripts. And inside the scripts, I'm going to create a new script called Game Manager. If you spell the Game Manager the way I spelled it, Game Manager with capital G and M, it is going to show as a gear. Now you might have guessed this script will be responsible for the whole entire game. I like to keep one script for the whole entire behaviors because then it's very simple to navigate to your problems if you have any problems. So we're gonna drag our game manager, drop it into our game manager game object in our hierarchy, and now we have a game manager script attached to our object. So we're gonna open the game manager and we're going to populate it. Now if you don't know what these two methods do, is very simple. It even says in here, this start method will be called once when the actual game starts, and then this update will be called every single frame. If you want a vsync update that only updates a set amount of times, which is 60, we can use a fixed update function. This will be called, and it even says in here, this function is called every fixed frame rate. So we're gonna delete this for now. Actually, we're gonna delete everything for now, and we're going to start from scratch. Back into our game, we want a prefab of the game object that we want to spawn somewhere up here, and then it will fall down into our bucket somewhere down here. So let's create a game object. And for now, we're going to simply use a sphere for that. Don't forget to change the transform of any game object into transform 0, so then it shows up in your game. By default, a sphere object has a sphere collider. So we're going to remove that. We're going to press F to focus on that game object. We're going to add a 2D component. So we're going to search for 2D, and then we have in here all of our 2D functions. For now, we want a 2D circle collider. Now we're going to see a very thin circle appear in our scene view. If this circle doesn't appear in your view, you probably don't have this gizmo selected. So select that, and then you can see the outlines. The optional thing to do is to define a color for this object. Now, if we switch from the 2D view into 3D view, we're going to see that the sphere is actually 3D. And in the start of this video, I said that we're going to build a 2D game. So to do that, I am going to remove this mesh renderer, and now we have just a collider. To add an actual sprite into this game object, we're going to go into the Components tab, and we're going to search for Sprite Renderer. This is your sprite renderer. In here, you can drop in any sprite you want, and it will show up in here. So I'm going to select a white shape, and now we have a white sprite renderer, and it shows into our game as well. Now you might have noticed that we have this circle collider not aligning with the lines of this sprite. You can easily change that by changing this radius of your circle collider. Now we have a sphere object that we can use as a prefab. What we're going to do now is drag this sphere object and drop it somewhere into your assets folder. Now we have a sprite. The reason why we need a sprite is because later we can just instantiate this sprite as many times as we want. So we're going to delete it from our scene, and we're going to go back into our game manager script. In here, we're going to create a reference to that prefab, and we're going to say public game object prefab instance. Now we have a reference of this prefab instance. After we created a prefab instance, we want to do something with this prefab instance. What we want is some function to instantiate this prefab instance. So now we're going to go back to our update function, or you can use a fixed update function as well. And inside this function, I'm going to define a method to instantiate this prefab instance. To instantiate it, for now, I'm going to use a input from my keyboard to know when this prefab instance will be instantiated. So to do that, I'm going to say if input dot get key down key code dot space. You can use any code. You can use A, you can use B, you can use R, you can use whatever you want. For now, I'm just going to use space. After I press the space key code, everything that's inside these brackets will execute. So in here, we want a set function that instantiates this prefab instance. To keep things simple, I'm going to create a new function, and I'm just going to call it instantiate. I'm going to copy this instantiate prefab, and in here I'm going to say public void instantiate prefab. Now we have a separate function that we can do whatever we want. Inside this function, we're going to call a method called instantiate. This instantiate takes in a parameter of type game object. So you might have guessed it, we're going to use this prefab instance. And now this will instantiate a prefab instance every time we click the keycode space. So let's save that and let's go back to our game. If we take a look at our game manager game object, we're going to see a new slot for our prefab instance. We're going to drag our sphere and drop it inside this prefab instance. Now let's simply hit play and let's see what happens. I'm going to press space and we're going to see if anything happens. And indeed, it spawns in a new prefab. Now what we're going to do is open this prefab by simply double clicking it. And now in here, let's add in more components. One of the components is rigid body. For this particular prefab, we're going to use rigid body 2D. Now, when you add a rigid body, the mass will be defaulted to 1. What I like to do is make it a little bit lighter to maybe 0.1. And now we have a rigid body. What this rigid body does is it adds some physics into this game object. So let's see if this game object goes and falls into the ground. Okay, we can see that it actually drops down. We can spawn as many as we want. And now, as you can see, we have some garbage that we just created in here. Okay, perfect. Now let's create a bucket that actually collects those points. So we're going to create a empty game object and we're going to call it bucket. Now inside the bucket, I'm going to create some empty game objects, and then using these, I'm going to try and create some sort of a bucket looking sprite. Okay, now we have a nice bucket. I know it's not the prettiest bucket in the world, but it's going to work just fine. Now we only have the sprites of this bucket. Let's add in a collision system. So to do that, I'm going to create another game object and I'm going to call it collision. And then inside the collision, I'm going to create some collision objects. Okay, now I've added some collision to this bucket. Straight away, if we play the game, this bucket should collect the dropped items. And it clearly does. Although these prefabs may be a little bit too big. So I'm going to go inside the prefab and I'm going to scale it down to 0.7. Now it kind of makes a little bit more sense. Okay, this is what we got so far. We got a bucket full of small circles. Okay, now I'm going to spawn this instantiated prefab using a get key instead of a get key down that we had earlier. So if I press the space key, it is going to spawn in a massive amount of spheres. Now, one problem that we're facing right now is that it spawns them in the same position. Let's create a function that lets us spawn these prefabs into random positions somewhere up here. So to do that, first we're going to need a reference to the exact position that we want to spawn in our prefabs. So let's create a transform. Let's call it public transform spawn position. Now we have a transform reference to the spawn position that we want to spawn these prefab instances. Now, since we don't want them to spawn in the same position, we want to define some variables in here. To actually vary the distance between the starting position and the distance between the x-axis, we're going to use a variable to do that. So to do that, I'm going to say public load and I'm going to just call it spawn distance. I'm going to default this to 5. You can default it to any number you like. And now let's actually use this spawn position and this spawn distance. Now to change the actual position of this instance, there's a couple of ways. My favorite way is to actually save the instance of this spawned prefab into a variable. So we're going to say game object prefab, and we're going to simply say is equal to this just spawned new prefab instance. So to actually spawn the instance in the spawning position that we just created, we can just add it in here as a vector3 position. So we're going to do that. We're going to say spawn position. Now to actually spawn this instance, into this spawn position, we can simply add in this parameter, and then inside we're simply going to pass in this spawn position, and that's it. Now to actually vary the distance between this spawn position, we're going to use this float variable that we just created. So after we create this prefab, we're simply going to say prefab.transform.position is equal to new transform dot is equal to new vector 3. We can use vector 2's as well, since we're using but I'm going to keep things simple and I'm going to simply use a vector 3. So if we check into our game, we want to vary the position of x in here. So we want x to vary from all the way here all the way back to here. So we're going to say vector 3. For the x-axis, I'm going to use this spawn distance. So I'm going to say spawn distance. And then for these parameters, we can just use prefab.transform.position.y. And then for the z-axis, we can say the same. And we obviously changed the z-axis. And that's it. Now if we hit save, now we're obviously going to see a spawn position transform. We're going to create a empty. We're going to position it to 0, and then I'm going to move it somewhere up here. Now if I hit the key space, it is going to spawn them completely outside of our game. Okay, let's fix that. So to fix that, what we're going to do is delete this spawn position from here. And then instead of saying prefab.transform.position.y, we can say spawn position dot transform dot position dot y, and then we can say the same thing for the z-axis. So we're simply going to change the prefab to spawn position. Now the prefabs should spawn somewhere up here, and it's telling us that we didn't define a variable in here, which is completely my fault. So in here we don't have a spawn position. Let's simply drag this and drop it in here. And now if I hit space, yeah, they spawn in right here. If we decrease the spawn distance to 1, they're going to spawn in at a different position, which is exactly what we want. Now let's make the spawn distance vary from, let's say, I don't know, here to here. And to do that, I'm going to use a random function. Okay, to randomize this spawn distance, we are going to use a math.random. Now, you can see that it doesn't appear as a function in here, and that is because we're not using a import up here. So we're going to say using system.collections. And the way we're going to use the random function is by saying random.range. And we want the range to vary from the minimum all the way up to the maximum. So as the minimum, we're going to use this spawn distance. So we're going to say minus spawn distance to spawn distance. That is going to vary from -5 to 5. If we try out this code, this is the result that we're gonna get. So what we got in here is basically raining circles, which is kind of nice to look at. Anyway, that is not what we're here for. Okay, now let's make a function that spawns them using a time function. So to do that, the best way that I found is by using a Ienumerator. So the Ienumerator works like this. After you create a Ienumerator, it's going to tell us that it needs a return function. So before we return anything, we're going to say while true, yield return new wait for seconds, and then inside the wait for seconds, for now we're going to say 0.5f. And now we have a Ienumerator. And all that's left for us to do right now is to actually start this coroutine. So to start it, we need a start function, and then in the start, we're simply going to say start coroutine, and there we have it. Now we have a numerator that executes every 0.5 seconds. Now let's tell it to actually do something every 0.5 seconds. So obviously we want to execute this function. So let's copy that, let's paste it down here, and let's remove it from the update function. Okay, now if I hit play, we're going to see that they spawn automatically. We can of course change the distance to maybe 1. They will spawn in very close to each other. You can say that is 100, so they spawn in further. Anyway, that is completely up to you. Okay, now since this game is kind of progressive, we want this wait time to vary. So the greater the score, the less this time value is. So let's say public float time, or actually let's say public float start time. We're going to default it to 1, and then in here we're going to say start time. Okay, now let's make a function to let us know how many circles we have in this bucket. To do that, we're going to go back to this collision, and then we're going to add in another collision in here. We're going to say create empty, and then we're going to call it trigger. We're going to add in a component of box collider 2D, and then we're going to check this is trigger. Obviously you're gonna shape it the way you want to shape it, and now we have a trigger collider. Okay, now to read the collisions from this box collider, we need a script that is attached to this game object. So let's create a new script. Let's call it whatever you want. I'm gonna call it trigger detection. I'm going to grab this trigger, and then I'm going to drop it into this trigger. So the only function that this trigger detection will do is check for collisions. So to check for collisions, we're going to say on trigger enter. And then to actually check if the circle has left this bucket, we're going to check on collision exit. Now we have two functions. We have a collision enter and a collision exit. So I'm going to delete this summary. And now what we want is to send information from this trigger detection back to this game manager. So there is a couple of ways of doing that. We can do the same method that we did in here with dragging and dropping things into this script. But I'm going to show you a new way. First, we're going to say public game manager manager. And then I'm going to say start, and then in the start I want this manager to be instantiated into this actual manager. So to do that, I'm going to say manager is equal to find object of type, and then inside obviously I want to pass in game manager. Now this will find a game manager game object. Now since we want to change the score depending on the on trigger enter, we want a variable in here that indicates the actual score. So we're going to say public integer, and we're going to call it score. The score will be obviously 0. After we create a score, we want another public integer bucket. And after we create the score integer, we want another integer that indicates the amount of circles that are inside the bucket. So we're going to call this bucket score, and then this will send in information to this bucket score. So instead of just saying manager dot bucket score plus plus, what we're going to do is a function to add these scores. Now the reason why we want the functions is because later on we might want a score multiplier. So let's do that. Let's define two new functions. Let's say public void add bucket score, and let's define another function called public void remove bucket score. And now since we're always going to have one object removed, we don't need a input in here. So for now, this is simply going to decrease this bucket score. So add bucket score will do bucket score plus plus, and obviously remove bucket score will do bucket score minus minus. And that's basically it. Now let's add in those two functions into trigger detection. Let's simply say manager dot buckets dot add bucket score, and then in here we're going to say manager dot remove bucket score. And there we have it. Now let's actually see if any of this has worked. We have a manager. We don't need to drag and drop in our manager in here. And we have our actual game manager in here. I'm going to decrease the distance to 1, and I'm going to increase the start time to maybe 1.5. Let's start the game and see what happens. Okay, before anything other happens, we're going to see in here that the trigger has found the game manager. And now let's see if this actually triggers the game manager and the score rises. After having set your trigger, your box collider 2D at his trigger, we're gonna simply hit play, and we're going to see that they fall into the collision box and nothing happens, even though we have connected our game manager and trigger detection. The problem is that we're using on trigger enter. This collision only works with 3D colliders. So to fix that, we're simply going to add a 2D in here. Now this will work with 2D collisions. So I'm going to delete the prints that I made earlier, and then I'm going to fix this error that I made in here, which is on collision exit. So I'm going to rename this into on trigger exit, and I'm going to say manager dot remove bucket score. And now if we go into our game manager, we should see this bucket score increasing. Okay, as we can see, it works clearly fine. Okay, now let's make a function that if the bucket score hits like 10, for example, the score goes from the bucket score over to the main score. And after we transfer the bucket score into the main score, we want our bucket to become empty again. So to do that, we need the references that have entered this collision. So back into our trigger detection, we have this other function that we can use to transfer data from here over to here. So let's create an array. Let's call it public game object, make it an array of game object, and bucket prefabs, or you can call it whatever you want. Now what we want in here is this bucket prefab to have all the prefabs that are inside the bucket. So to do that, we're going to have to send it from here over to there. So back into our game manager, we're going to define a game object, and we're going to simply call it prefab. Every time we execute this function, we want this game object array to increase. Now, the problem is that if you use this type of array, you cannot increase or decrease its components. So what we're going to do is do a array list. Now to define a array list is as simple as saying array list bucket prefabs. And then you want to instantiate this bucket prefabs into new array list and empty brackets. Now in here we want that array list of bucket prefabs to add in this game object in here. So we're going to simply pass this prefab into this function. And there we have it. We have just added a new prefab into this bucket list. Now we want to do the same thing for removing the bucket score. And that is basically it. We have a typo in here that I don't know how to write apparently. And now we're increasing or decreasing the array list. And then in here we're simply going to pass in this other in here. So we're going to say other dot game object, and then we're going to do the same thing, other dot game object. So hit save in both of these scripts, And now we have a array list that does not appear into bucket score. So to do that, let's actually do some UI in here. So we're going to create some simple UI and I'll be right back. Okay, I've created a score and a bucket amount. Now let's create some empty slots for those functions. Okay, I've created a score and a bucket. The bucket will change every time this add score or remove bucket score gets called. So it's going to be the same function executed in both of these methods, and the function is bucket.text is equal to bucket prefab.length, and then add a toString function, and then simply copy that back over to remove bucket score. Don't forget to drag and drop these into your UI element, and then we can hit play. We can see that the bucket amount works perfectly fine, and if we try to shake the actual bucket, we're gonna see that the bucket amount actually decreases. Okay, we're approaching the end of this tutorial. I hope you've been enjoying it so far. And so far what we've done is that we've been able to catch the circles that have been falling in here, and we've been able to add the actual prefabs into a array list. Now let's make a function that destroys those arrays and then turns that score into the actual score. So let's do that. Okay, so for some reason the for loop that we're using to destroy these items in here would not work, and what I did is I defined a bucket container game object, and then every game object is moved inside of this container, and then we can simply just destroy every element inside of this container easily. So here is the game working. I've currently set it to 20. I should set it a little bit lower, maybe to like 12 items inside the box. And when the bucket reaches 12, it should destroy them and it should add them to the overall score. Okay, so the way I've done this is by defining a new bucket container and then simply moving the items that are spawned inside of this bucket container. The code for that, if you can't follow the code, you can always find it in the video description down below, as always. And here is what it does. We have these two functions, add to the bucket score and the remove one. And all the add bucket score does is it sets the prefab parent to that parent that we just set. So this one, bucket container, and then it checks if it has reached the maximum. If it has, it simply destroys them. So to destroy them, I'm using a while loop, because for some reason the for loop would not work no matter what I did. So I'm using a while loop, and I'm asking if, and I'm asking while the bucket container has any child inside it, simply just destroy it. And then obviously I'm adding to the score. And if we want to remove it, we basically reverse the process, and then we simply update the scores. So we're almost done with the game, and all that's left for us to do is to track the input of our mouse. Or maybe you're using a Android device or maybe an iPhone, and you want to track the input of your device of choice. Okay, now let's implement the function that checks if we have pressed the mouse, and then if we have, it's simply gonna track the mouse input, and then it's going to translate it into the movement of this bucket. So to do that, I'm going to create a new header in here. I'm going to call it input, and then I'm going to say public float x value. Now to get the exact reading of this value that comes from the mouse, we're going to need to use the update function instead of the fixed update function. So let's do that. Let's say simply update, and then into the update we're going to say the x value is equal to input dot get axes, and in here we're going to be careful to spell it right, and to spell it right is mouse x. This will give us the x value of our mouse movement. So let's do a quick test. Let's see if it actually works. So let's hit play, and it's yelling at us because the mouse axis is not set up. Okay, I may have made a slight error. I misspelled mouse with moose. So let's simply forget that I've done that, and let's see if it actually works. Okay, now we got a reading. As we can see in the input in here, it is showing us the input value. And that's basically all we need to move this around. Now let's try to move this bucket around using our mouse. So to move this bucket around, first we need a reference to this bucket, which is this one right here. So into our bucket header, we're going to say public game object bucket. And then down here, okay, I've named it bucket game object. And then in the update function, we're simply going to pass this value into the bucket game object. And to do that, we're simply going to say dot transform dot position is equal to new vector3, and then since the two values are going to be always at 0, we can say for the first parameter we're going to pass in this x value, and then for the two other ones we're simply going to say 0. And now this will produce a brand new error. Let's see what it is. So let's hit play. Okay, we have an unassigned variable. Simply drag in your bucket and drop it into your slot. And now this is the error that I told you about. So the error is that it doesn't work properly. That's one way of saying it. It does not work properly. Now let's try to fix it. So instead of just simply passing in a value in here, we need to increase or decrease this value, since this value becomes 0 when the mouse is stationary. Okay, let's see how we can do that. Then the other error that we had is the y value is changing to 0. So to fix that, a simple fix is by saying bucket game object dot transform dot position dot y. Okay, the y axis is now fixed. Now let's work in this x value. Let's define a private variable and let's call it something like x value translated. And what we're going to do with this value is down here we're going to say x value translated is equal to plus x value translated plus equal to x value. Now this is going to produce another error that we just saw earlier, and the error is that the bucket moves way too far. So to do that, we're going to introduce a new variable, and the variable is going to be called public float maximum movement. You can call this whatever you want, as always. So we're going to copy that, paste it in here, and instead of doing just minus that, we're going to subtract. So let's hit save. Let's not forget to copy the x value and paste it in here. And now let's see what we get. Let's set for now the maximum movement to 0.1, and let's see if it has any effect. Okay, the problem is that it's still moving way too fast. We need to increase this maximum movement. Let's set it to something like, I don't know, 50, and it's still way too quick. So let's try to set it to a higher value, like 100. And now it seems like it's working a little bit better. Now let's add a function to detect if we are pressing the mouse so that this can actually move around. So if you open up Unity scripting and into input, we're going to see that it's very simple to detect input movement. So to do that, we're simply going to copy this function that says input get button down fire one. The fire one is your left click. So we're going to copy that into our update function. We're going to paste it, and then inside the brackets we're going to put our code. And with that, if we click, we should be able to move this around. And now we have a slight error. As always, the error is that this detects only when the button is down. So to fix that, simply delete the down and your game should be working fine. There it is. Okay. One last error that I want to fix is that if you move this too quickly. So if we have some prefabs inside the bucket and we try to move the bucket quickly, we're going to see that they fall. Now, if you try to mess around with the rigid body, you can basically do nothing. So the only workaround for that I found is by using a Lerp function. What a Lerp function is basically it lets you move a certain game object a little bit slower than it actually does. So the syntax for that is rather simple. Instead of just saying new vector3, we're going to say vector3 dot lerp. Now, if we hover over the lerp, we're going to see that it takes in three parameters: the vector a, the vector 3, and the vector a, the vector b, and the time that you want this lerp to take place. So let's declare a time function. Let's say public float lerp time. And then since we have the desired position right here, we only need to have a current position. To get the current position, we're going to say bucket game object dot transform dot position. And now we have a current position, which is this one. We have a desired position, which is this one, and we only need the time. To add the time, we have this lerp time, which I forgot the semicolon. We have the lerp time. We're going to default it to 1. And then in here, we're simply going to pass it as lerp time times time dot delta time. We always need this time dot delta time. And now this is yelling at us because we can't do this. So what it says in here is that it cannot convert from a float into a vector3. So simply cast it as a new vector3 in here, and everything works perfectly fine. So we hit save, we go back to Unity, and we test to see if it works. And we can immediately see that it lerps the function. Maybe a little bit slower, so we can always change the lerp time to maybe 5. And there we have it. We have a bucket that collects our prefabs. Okay, for the last thing that we need to add is a way to know if this prefab has gone around our bucket and it fell into the void. So to do that, we are going to define a new game object. We're going to reset it to 0, and then we're going to move it down here. Inside it, we're going to define a box collider 2D, and then we're going to stretch it all the way over so it covers basically all the ground. Inside it, we're going to define a new script, and I'm simply going to name it trigger detection 1. The function of trigger detection 1 will be almost exactly the same as trigger detection 0, I guess. So I'm going to copy everything, paste it back to trigger detection, and then instead of passing in a add bucket score, we're going to create a new function in here. So we're going to say public void, and I'm going to call it lose game. So lose game will basically end everything, or maybe you want to start over. So an easy way to start over is by reloading the scene. The way you reload the scene is first you need Unity engine dot scene management, and then down here we say scene manager dot load scene, and in here we pass in the name of our scene, and in this case I have new scene. So I'm gonna copy new scene, paste it in here, and then into trigger detection I'm simply gonna say manager dot lose game. Okay, let's try to lose the game. And we can see that I forgot to make this as a trigger. Okay, Let's not forget to make the brand new box collider as a trigger. Let's move it down a little bit more. And now let's try to play the game. Okay, we can collect them, we can move around, and now let's try to actually lose. We can see that it restarts our game. Okay, that's about it, what I've planned for this video. I hope you've liked it. I hope you've learned something from it. I know it's very simplistic, and I know it doesn't have a very nice purpose to it, but that's all I prepared. Let's not forget to change the background color of this camera. Okay, so I've made a color change script that contains the code that smoothly transitions between the color of the background, and we can see it in action in here. It smoothly transitions between colors, and it kind of gives it a little bit of more life to our game. Okay, the code can be found down in the video description. This is the code. We have an array of 4 colors: red, yellow, cyan, and red. And then in here we have a update function that lerps the colors. So we have a lerp color, we have a lerp function, and as we know, lerp takes in a parameter A, parameter B, and it takes a time that function gets called. And then in here we get the component, the camera, and it changes the background color. And then this is a simple function that changes the index, this I in here, and this way it cycles through colors. Okay, thank you for watching. You can find the code in the video description, as long as the full entire game, if you want to grab it. Maybe you want to do something with it, maybe you want to improve it, add in new function, add in new particle systems, I don't know. You do whatever you want. Thank you for watching. I'll see you in the next videos.